Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning! Today, we will discuss the third conic section, which is ellipse. Ellipse is a set of all points in a plane, the sum whose distances from two fixed points is constant. The fixed points are called foci. Do you know that ellipse is like a flattened circle? But actually, circle is a type of ellipse. We will know why later on. Now going back to our definition, these 2 points that are fixed are called foci, or in singular form, it's called focus. So if we have here 2 fixed points, focus 1 and focus 2, the sum of their distances from a given point is constant. So whether we will be considering this point, or this point, or this point, or this point, or any other point in the plane, then we will still arrive at the same constant answer, which is the distance of the first focus to the given point plus the distance of the second focus to the same point is equal to 2a. To know what 2a means, let us proceed to the features of the graph of an ellipse. Let's start with the major axis. It is the longest diameter in the ellipse whose endpoints are called vertices. Considering our ellipse here, our major axis is this diameter, while our minor axis is the shortest diameter in the ellipse whose endpoints are called co-vertices. Considering our ellipse here, our minor axis is this diameter. So as I've said earlier, circle is a type of ellipse where the major axis and the minor axis are equal. Let's now proceed to the other features of the graph of an ellipse. First is center, which can be represented by point C. This is the point in the middle of an ellipse. We already discussed focus, or in plural form, foci. Now each focus is C units away from the center. Next are the endpoints of the axis. Let's start with vertices, which can be represented by point V. Each vertex is A units away from the center, while the co-vertices, point W, is B units away from the center. Now recall that the sum of the distances of the foci to a given point is equal to 2a, which is the entire diameter of the major axis. We will be using this equation to derive the equation of the ellipse. Let us first get the distance of the first focus to the given point, which is line segment BF sub 1. To get the distance of 2 points, we will be using the distance formula, which is equal to the square root of quantity x sub 2 minus x sub 1 squared plus quantity y sub 2 minus y sub 1 squared. Now letting our coordinates of the first focus be x sub 1, y sub 1, and the coordinates of our given point be x sub 2, y sub 2, we can now simply substitute. X sub 2 is x sub 1 is negative c, y sub 2 is y, and y sub 1 is 0. And since negative times negative is positive, our final distance for the first focus going to a given point P is the square root of quantity x plus c squared plus y squared. Let us now get the distance of the other focus going to the same point, that is line segment BF sub 2. In here, we will still be using the distance formula. However, our x1, y1 will be the coordinates of our second focus. Substituting the values, our x sub 2 is x, our x sub 1 is c, our y sub 2 is y, and our y sub 1 is 0. Therefore, line segment BF sub 2 is equal to the square root of quantity x minus c squared plus y squared. Since we already have our distances, we can now proceed on deriving our equation using this formula. We have here line segment BF sub 1 plus line segment BF sub 2 is equal to 2a. Since both line segments are radicals, we will first transpose the second line segment to the other side, making it negative. Let us now substitute the values. The first line segment is equal to x plus c quantity squared plus y squared. 2a will simply be copied, while the other line segment is square root of x minus c quantity squared plus y squared. To get rid of the radical symbols, we will be squaring both sides. This will give us the following results. The next step is to expand the binomial. So x plus c quantity squared is equal to x squared plus 2cx plus c squared, while quantity x minus c squared is equal to x squared minus 2cx plus c squared. Now remove the common terms on both sides and you will arrive at this result. Now let us transpose terms from both sides so that we can isolate the term with the radical symbol on the left side. Now looking at the right side, we can still simplify negative 2cx minus 2cx, which is equal to negative 4cx. Now as you can see, 4 is common on all terms, so we will be dividing each of the terms to 4, giving us this result. Let us now get rid of the radical symbol on the left term by squaring both sides. This will give us the following result. Expanding this binomial will give us x squared minus 2cx plus c squared. Now distributing a squared to each of the terms in the parentheses will give us this result, while the right side remains the same. Canceling out common term on both sides will give us this result. Let us now transpose terms from both sides so that we can regroup terms with common factors. The common factor in these two terms is x squared, while the common factor of these two terms is a squared. Now recall that a squared minus c squared is equal to b squared in the Pythagorean theorem. Now dividing each term of this equation by a squared b squared will give us x squared over a squared plus y squared over b squared is equal to 1, which is the equation of the ellipse. We have here the graph and equation of ellipse. If our center is at the origin, our center is at 0, 0. We have two types of ellipse here, the one with the horizontal major axis and the one with the vertical major axis. Inspecting their corresponding equations, only the values a squared and b squared were interchanged. Now, if our center is not in the origin, it could be in any point with coordinates hk. In that case, look at our equation. We simply added minus h in x and minus k in y. Still, we have the same horizontal and vertical major axis. And still, only the values a squared and b squared were interchanged to classify them. Familiarize these equations and their corresponding graphs because we will be using them in our next video lessons all throughout the topic ellipse. Special shout out to my awesome students Mike, Kim, Zoe, and Christopher, and to my very own best friend Carol May Hinampas, whose favorite line is Kita ta puhon. That is all for today. Thank you and see you on our next video lesson. Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning! For today, we will rewrite general form to standard form of an ellipse. From our previous video, I have discussed how to derive the equation of an ellipse. If our vertex is at 0, 0, our general form looks like this. There are 3 terms, and our standard form looks like this. Well, if our vertex is at any point of the circle or HK, we have here our general form with 5 terms, and our standard form looks like this. Let us start with number 1. We have here 3 terms, which looks like this. Therefore, our expected answer should also look like this one. Our expected answer should have 1 on the right side. So in order to do that, we have to divide 144 to itself to have a result of 1. And since this is an equation, whatever we do on the right side should also be done on the left side to retain the equality symbol. So we will divide each term by 144. So our right side now will be equal to 1 because 144 divided by itself is 1. And then look again at our expected answer. We should only have x squared and y squared as our numerators. Going back to our first term, for us to only have x squared, we should remove 49 by dividing both numerator and denominator by 49. 49 divided by 49 is 1, so we don't have to write it. And 144 divided by 49 is 9. Do the same on the second term. To eliminate 9, we have to divide the numerator and the denominator by 9. 9 divided by 9 is 1, so we don't have to write it anymore. And 144 divided by 9 is equal to 49. This is our final answer. Now you might be wondering, which one here is our a squared and our b squared? Just remember that the bigger denominator is our a squared, and the lesser one is our b squared. So we have actually formed this standard form. We are now on number 2. As you can see, there are 5 terms here in our left side, which looks like this. Therefore, our expected answers should also look like this one. First thing that we have to do is to place a number on the right side. Since negative 32 is on the left side, we have to transpose it to the other side, making it positive 32. Next step is to regroup terms with the same variable. We have here 16x squared and negative 32x as one group, plus the other group is 4y squared plus 16y. Now before we proceed, check each group if there is a common factor. There is 16 on this first group. 32 divided by 16 is 2. Just copy x, and on the second group, our GCF is 4. So what's left inside the parenthesis is y squared plus 4y. Now going back to our expected answer, we should have here a binomial raised to 2. Therefore, we will be completing the square here. To do that, let us first copy this one, leaving a space for our third term. Let us first focus on our first group. Remember that our third term depends on our middle term. We only have to divide our middle term by 2 and square whatever is the result. So negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. Now remember that if you will place something on the left side, you will also do the same on the right side. Since there's 16 outside, we will add 16 times 1 on the right side. Next is this group. 4 divided by 2 is 2. 2 squared is positive 4. Therefore, we also have to add 4 times 4 on the right side. We can now factor this trinomial into a squared binomial. In the first group, we have x minus 1 that is taken from negative 2 divided by 2, and in our second group, we have y plus 2 that is taken from 4 divided by 2, and operating the numbers here, we'll have 64. Going back to our expected answer, our right side should be 1. Therefore, we will divide this side by itself. Now remember, this is an equation, so what we do on one side should also be done on the other side. Therefore, we will be dividing both the terms on the left side by 64. Now our right side is 1. Going back to our expected answer, we should only have the squared binomials as our numerator. Now, in order to remove the leading constants in our squared binomial, we have to divide it by itself. We have 16 here, therefore, 64 divided by 16 is 4. On the other group, we have here a leading coefficient of 4. Therefore, we will be dividing 64 by 4. That will give us 16. We have arrived at our final answer. Now remember that our bigger denominator is our a squared. In here, our bigger denominator is 16, while our smaller denominator is our b squared, which is here 4. We have actually formed this standard form here. Special shout out to my awesome students, Rachel Antivola, Tricia Surizo, Mary Hope Salon, Zlee, and Leah Lagua, the content creator of Leah and Irvin Vlog. Please subscribe. That is all for today. Thank you and see you on our next video lesson. Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning! In this video, we will be rewriting standard form to general form of an ellipse. Our item here is a standard form of an ellipse with vertex hk, which looks like this. So our goal is to come up with its general form. But notice that our given here started with a term in y variable. So we will simply interchange their positions and we are ready to solve. Remember that our bigger denominator is our a squared, while our lesser denominator is our b squared. Therefore, this standard form actually looks like this. And we are to provide the general form here, which is not in fraction form. So our first step here is to eliminate fractions by thinking about the LCD or the least common denominator. Since there is no number that can be divided in both 4 and 9, Our LCD is simply the product of 4 times 9. We will be distributing this one to each of the term. Let's start with the first one. Since 4 is common here, we will be canceling it out and we are left with 9. And we'll simply multiply 9 to the numerator. Next is, on the second term, 9 is common here, so we will be canceling it out. What's left is 4 multiplied to the numerator. Lastly, 1 times 4 times 9 is equal to 36. As you can see, there is no more fraction here, and we can now proceed. In our first term here, we have to expand this binomial, so we have here x minus 4 multiplied to itself. Same with the second term here, we also have to multiply y minus 3 to itself. Let us now perform the FOIL method. We have here x times x is equal to x squared, x times negative 4 is negative 4x, negative 4 times x is negative 4x, and negative 4 times negative 4 is positive 16. On the next term, we also have here y times y is y squared, y times negative 3 is negative 3y, negative 3y times y is negative 3y, and negative 3 times negative 3 is positive 9. Now, as you can see, there are still like terms inside the parentheses, so we will first perform this one. For our first term, negative 4x minus 4x is 8x, while in the second term, negative 3y minus 3y is negative 6y. We will now distribute 9 to each of the term here. 9 times x squared is 9x squared, 9 times negative 8x is negative 72x, 9 times positive 16 is positive 144. And then, 4 will be distributed here, so that's 4y squared, that's negative 24y, and then 4 times 9 is positive 36. Going back to our expected answer, we will be writing the term with x squared. So that would be 9x squared. Next is y squared, so that's plus 4y squared. Next term is with x, so that is this one, negative 72x, followed by term with y, so that's negative 24y. Next is e, which means constants. So we will be writing all of the constants, 144, 36, and 36 on this right side will be transposed to the left side so that we will have 0 on the right side. Our constants here can still be simplified, so we'll simply copy everything and then perform 144 plus 36 minus 36 is equal to positive 144, and this is our final answer. Let us now proceed to the next item. As you can see, this is still in standard form with vertex hk. 36 is our a squared, while 20 is our b squared. Therefore, our given is actually in this standard form. Our goal is to come up with this general form. To do that, we have to remove all of the fractions here by multiplying it to its LCD. Recall that in number 3, our denominators are 4 and 9. Since they don't have a common factor or a number that can be divided in both of them, our LCD is simply the product of 4 and 9. However, in this item, 20 and 36 have something in common. We could start with 2. 20 divided by 2 is equal to 10, while 36 divided by 2 is 18. 10 and 18 still have something in common, which is 2. 10 divided by 2 is 5. 18 divided by 2 is 9. We will stop here because we cannot think of any other common factor between 5 and 9. Our LCD here are the numbers outside. That is 2 times 2 times 5 times 9, which is equal to 180. Therefore, we will multiply each of our term in the given with 180. Starting with the first term, 180 divided by 20 is equal to 9. So we will be writing 9 here multiplied to the numerator. On our second term, we have here 180 divided by 36 is 5. So we will be multiplying 5 to the numerator. And then 180 times 1 is 180. As you can see, there's no more fraction here and we can now proceed. Let us expand these binomials. So we have here x minus 2 multiplied to itself and y minus 3 multiplied to itself. Let us now proceed with FOIL method. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. On this side, y times y is y squared. Y times negative 3 is negative 3y. Negative 3 times y is negative 3y. And negative 3 times negative 3 is positive 9. Since there are like terms in our parentheses, we will be combining them. Negative 2x minus 2x is negative 4x, while negative 3y minus 3y is negative 6y. Let us now distribute 9 to each of the term in the parentheses. 9 times x squared is 9x squared. 9 times negative 4x is negative 36x. 9 times 4 is positive 36. We will also do the same on this side. That is 5 times y squared is 5y squared. That is negative 30y. And then 5 times 9 is positive 45. We will simply copy 180 on the right side. Now going back to our expected answer, we will start writing the term with x squared. So we have here 9x squared followed by y squared. So that's positive 5y squared. We also have here term with x. So that's negative 36x. The term with y. So that's negative 30y. And then e represents all of the constants. So we have to write positive 36, positive 45, and our 180 here will be transposed to the left side so that our right side will only be 0. As you can see, our constants here can still be simplified. That is 36 plus 45 minus 180. That is equal to negative 99. And this is our final answer. Special shout out to my awesome students Hannah Pabayo, Sahira Abbas, Ruiza Valdeweza, and Joanna Herrera, and to my annoying boyfriend who's not following instruction, Frankie Samson, shark out. That is all for today. Thank you and see you on our next video lesson. Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning! For today, we are going to graph ellipse. Before that, we have to remember the features of the graph of ellipse. We have here major axis, the longest diameter in the ellipse, whose endpoints are called vertices. The minor axis is the shortest diameter in the ellipse, whose endpoints are called covertices. The center, which is represented by C, is the point in the middle of an ellipse. Foci is the plural form of focus, represented by F, which is C units away from the center. The vertices, which is represented by V, is A units away from the center, while the covertices, which is represented by W, is B units away from the center. We also have to remember the corresponding graphs depending on the center. If our center is at 0, 0, we have here the following equation. And if our center is at HK, we have here another equation. With this, we are now ready to start graphing an ellipse. Let's start with the first item. 25x squared plus 9y squared is equal to 225. This is in general form. If there are 3 terms here, that means to say that our center is at 0, 0. Let us now convert this one to standard form. Recall that the right side of the standard form of an ellipse is equal to 1. That means to say we have to divide all terms by 225. Our right side is now 1. Recall also that our numerators in the standard form should also be x squared and y squared. Therefore, in the first term, we have to divide both numerator and denominator by 25 and the second term by 9. So in our first term here, 25 divided by 25 is 1, so we don't have to write it anymore, and 225 divided by 25 is equal to 9. For our second term, 9 divided by 9 is equal to 1, so we don't have to write it anymore in our numerator, and 225 divided by 9 is equal to 25. This is now our standard form. From this, we can now get our values. We have here our center is at 0, 0. Our a squared is our bigger denominator, which is 25. So square root of 25 is equal to plus or minus 5. Our b squared is our smaller denominator, which is 9. Therefore, square root of 9 is positive or negative 3. While our c squared is equal to a squared minus b squared. Substituting the values, our a squared is 25 minus our b squared is 9. That will give us a value of 16. Therefore, our c squared is equal to 16, wherein our c is plus or minus 4. Now, since we already have our center, our values of a, b, and c, we are now ready to graph using the Cartesian plane. Let us first plot our center, which is at the origin. That point is 0, 0. Now, plotting the rest of the points depends on our standard form. As you can see, the second term has a bigger denominator compared to the denominator of the first term. Therefore, this ellipse has a vertical major axis, since our a squared is in the second term. So we have to plot our vertices and our foci vertically. Let's start with A. A is the distance from our center going to the vertices. So we have to count 5 units up and down. So we have here the following points. Our first vertex is at 0, 5, and the other vertex is at 0, negative 5. We can actually interchange the labeling here of the vertices. It doesn't really matter which one is our vertex 1 and vertex 2. Next is our B. B is the distance from the center going to the co-vertices. So from 0, we have to count 3 units to the right and to the left. That points are negative 3, 0 and 3, 0. Finally, we have our C. Our C is the distance from the center going to the foci. So from our center, we have to count 4 units up and down. Therefore, the coordinates of our foci are 0, 4, and 0, negative 4. We can now create our graph using the points of our vertices and co-vertices. This is how our ellipse looks like. This is now our second item. As you can see, this is in standard form with 5 units on the left side. Therefore, our expected center here is any point with coordinates hk. Let us now make this into standard form. For our first step, we have to regroup terms with the same variable, and also our constant should be on the right side. Since 16 is common in our first group, we will be factoring it out, so what's left inside the parenthesis is x squared plus 96 divided by 16 is 6x. For our second group, we have here the common factor of 7, so what's left inside the parenthesis is y squared plus 14 divided by 7 is 2. And since we transposed 39 on the other side, it became negative 39. Now, for each of our term here, we have to complete the square. Starting off with the first term, we have added here 9. That is because of our middle term 6. 6 divided by 2 is equal to 3. Whatever is the answer, squared it, so 3 squared is equal to 9. As you can see, we also added 9 on the other side, but we also multiplied it to 16 because there is 16 in the left side. For our second term, we added here 1. Again, that is because of our middle term 2. 2 divided by 2 is equal to 1. 1 squared is equal to 1. We have also added 1 on the right side, multiplying it to 7 because there is 7 in the left side. We now have the following squared binomials. For the first term, we have here x plus 3 quantity squared. 3 is taken from our middle term 6, that is 6 divided by 2 is equal to 3. While on our second term, we have here x plus 1 raised to 2. 1 is taken from the middle term 2, because 2 divided by 2 is equal to 1. While our right side is equal to 112. The next step here is to divide all terms by 112 because the standard form of an ellipse has a right side equal to 1. So we have here 1 in our right side. Also remember that our numerators should only be the squared binomials. Therefore, we have to eliminate 16 in our first term and 7 in our second term. To do that, in the first term, we have to divide the numerator and the denominator by 16. 16 divides 16 is 1, so we don't have to write it anymore, and 112 divided by 16 is equal to 7. For our second term, we have to divide the numerator and the denominator by 7. 7 divided by 7 is equal to 1, so we don't have to write 1 anymore in our numerator, while 112 divided by 7 is equal to 16. There is actually a shortcut here. The leading coefficient of the first term will be the denominator of the second term. In this case is 16. While the leading coefficient of the second term will be the denominator of the first term, which is 7. With this standard form, we can now get our values. Starting off with the center, our h is equal to negative 3. That is because in our formula, that is x minus h. If minus is constant, therefore our h is negative 3, so that we can arrive with positive 3. Negative times negative is equal to positive. Our k is negative 1 because of the same explanation. Therefore, our center here is negative 3, negative 1. Now our a squared is taken from our bigger denominator, which is 16. Therefore, our a is plus or minus 4. Our b squared is taken from our smaller denominator, which is 7. Therefore, our b here is plus or minus square root of 7. Now to get our c squared, we will be using this formula. Since a squared is equal to 16 and b squared is equal to 7, our c squared is equal to 9. That means to say our c is plus or minus 3. Since we already have our values, we can now graph. Let us start with the center. This point is again -3, -1. Now before we plot our vertices, we have to take a look at our standard form. Since our a squared or our bigger denominator is in the second term, while our smaller denominator or our b squared is in the first term, then our ellipse here has a major axis which is vertical. Therefore, we have to plot our vertices and our foci vertically. Let us now plot our vertices using the value of a. We have here 4 units up and down from our center. Therefore, our first vertex is -3, 3, and the second vertex is -3, -5. Let us now plot our co-vertices using our value b. That is square root of 7, which is approximately 2.65. Therefore, we have to count 2.65 units from the center going to the left and to the right. So our first co-vertex here has coordinates -3 minus square root of 7, which is approximately -5.65, -1. And our next co-vertex is -3 plus square root of 7, which is approximately 0.35, -1. Let us now plot our foci using our value of c. That is 3 units up and down from the center. Therefore, our focus here has coordinates -3, +2, and -3, -4. Let us now plot our ellipse using the vertices and the co-vertices. We have here this graph. Special shout out to my awesome students and friends, Irby Zambaan, Faith Baconga, Anika Tabike, Kim Cloyd Eden, and Chester Coquilia. That is all for today. Thank you and see you on our next video lesson. Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning! In this video, we will be getting the standard form of an ellipse using its properties. Number 1. Find the standard equation of the ellipse whose foci are 0, -8, 0, +8, such that for any point on it, the sum of its distances from the foci is 34. Recall that our center is the midpoint of our foci, our vertices, and our co-vertices. Therefore, to get our center here, we have to get the midpoint of 0, -8, and 0, 8. Which is obviously 0, 0. Since our center is at 0, 0, there are two possible equations here. Since our focus 0, -8 and 0, 8 are found on the y-axis, we will be using this equation. Recall that our foci is c units away from the center. Therefore, our c here is 8. Which means our c squared is equal to 64. Also recall that the sum of the distances of the foci to a given point is 2a. Going back to our given, it states here that the sum of its distances from the foci is 34. Therefore, 2a is equal to 34. Dividing both sides by 2, we'll have here a is equal to 17, which means that our a squared is 289. Since we already have our c squared and our a squared, we will be getting now the value of our b squared. Recall that c squared is equal to a squared minus b squared. Simply substitute the values of our c squared and a squared to get our b squared. What are we going to subtract to 289 to get the value of 64? That is 225. Therefore, our b squared is equal to 225. With the values of our a squared and b squared, we can now complete our standard equation. X squared over 225 plus y squared over 289 is equal to 1. Number 2. Find an equation of an ellipse with center at 0, 0, one focus at 3, 0, and the vertex negative 4, 0. Sketch the graph. Since it is already stated that our center is at 0, 0, we have here two possible standard equations. As you can see, our focus is at the x-axis and our vertex is also at the x-axis. Therefore, we will be using this equation. Now, since the center is the midpoint of the foci, the vertices and the covertices, if one focus is at 3, 0, automatically the other focus is at negative 3, 0. Each of our focus is 3 units away from the center. Therefore, our c here is positive or negative 3, which means that our c squared is equal to 9. Going back to our given, if one vertex is at negative 4, 0, then the other vertex is at 4, 0. And since they are a units away from the center, our a here is positive or negative 4, which means that our a squared is equal to 16. Now to get our b squared, or the distance from the center going to our covertices, we will be using the same formula. C squared is equal to a squared minus b squared. Substituting the values, we have here 9 is equal to 16 minus b squared. Therefore, our b squared here is equal to 7, which means that our b is positive or negative square root of 7, which is approximately 2.65 units. So from the center, we can plot our covertices by counting 2.65 units up and down. Therefore, our standard equation here is x squared all over 16 plus y squared over 7 is equal to 1. And this is how our graph looks like. Number 3. The covertices of an ellipse are 5, 6, and 5, 8. For any point on the ellipse, the sum of its distances from the foci is 12. Find the standard equation of the ellipse. The midpoint of our covertices is our center. Obviously, it's at 5, 7. Since our center is in HK, there are two possible standard equations here. Since our covertices here are parallel to our y-axis, we will be using this standard equation. Remember that our covertices are b units away from the center, which means to say our b here is equal to positive or negative 1, making our b squared equal to 1. Now, recall that the sum of the distances from the foci to any point is equal to 2a. Our given states that it is equal to 12. Therefore, 2a is equal to 12. To get the value of a here, we will be dividing both sides by 2, having a result of 6. Therefore, our a squared here is equal to 36. Since we already have the values of b squared and a squared, we will simply substitute it to get our standard equation. Since we don't have to write 1 as our denominator, our final answer is quantity x minus 5 raised to 2, all over 36 plus quantity y minus 7 raised to 2 is equal to 1. Special shout out to my awesome friends and students, Kikit Ugmad, Clance Tamo, May Carmel Pelaez, Love Sarsalejo, and Marvin Von Balaguasa. That is all for today. Thank you and see you on our next video lesson.